After the Q data, the next one we have is the speed, travel time, and OD data. So speed is a fundamental measure of effectiveness for traffic operations. Speed is measured in two ways: time mean speed and space mean speed. We have discussed these things again in greater detail in chapter 2 of our video series, Fundamentals of Traffic Operations, on different type of speed: design speed, free flow speed, time mean speed, space mean speed, and everything in greater details with equations and stuff. I'm not going to repeat the same thing. Travel time to traverse a route from point A to point B is another fundamental MOEs for traffic engineering, which we have seen, and origin destination data is another important characteristics that may help in determining travel pattern. Typically it's difficult to collect the OD data. There are GPS based big data sources. One of the big data sources that we used to use is Streetlight, which is not in use much anymore. Streetlight has been acquired by Jacobs, I believe, and TxDOT in past used to have a contract with Streetlight to provide OD data, which is a sample OD, not an actual OD. So it's quite reliable but not fully reliable either. So OD data is an important another source of OD data is travel survey, which is done by MPOs and embedded inside travel demand model. So travel demand model works on the fundamentals of ODs. So that's the origin destination data. As a consultant, we barely go and collect this data. It's kind of difficult to do OD estimation or OD data collection. If we have to collect OD data, then we would use Bluetooth sensors, which can detect the Bluetooth devices and figure out the proportion of vehicles. Let's say a Bluetooth sensor is here, figure out the proportion of vehicle which is detected at two locations. OD data provides useful information on trips between the user-defined geographic zones or roadways. We have talked about the zones in traffic volume forecasting. This data set may have additional information related to mode of transportation, such as organizing data by pedestrian, bicycle, and freight. Additional information about probe-based data, Bluetooth sensor data, or floating car method. I believe floating car data is shown in this section. So first one is probe-based data, which is GPS-based data. Now one good resource to get GPS-based data right now is to get the data from TxDOT contract through Vijo, which provides the GPS-based data. However, it requires a heavy processing, and its use has been kind of limited in consulting works. Also, these databases and their use needs to be verified by independent agencies, like I mentioned earlier, for example TTI, on how and where we can use these databases. Currently, the GPS-based data is primarily used for research purposes. And they have limited use in consulting world. So that's the probe-based data. Then floating car data is to get floating car type data is a type of probe-based timestamp geospatial data that provides the speed and travel time. So it's pretty much when we collect data, we have the sub-consultant with GPS fit on the car and drive through the stream several times, so we can get the geolocated location and the timestamp, so we can calculate the travel time and travel speed. This should be noted that to get the OD data or the volume data, the quality of data depends on the percentage of sample size. So let's say we are calculating GPS data and we are trying to estimate volume, then we need to know what percentage of actual volume we are capturing, and if it's less than 10% of what we are capturing, then it's usually not good. However, to get the speed and travel time, speed and travel time. We do not need to calculate gather data on all the vehicles on the roadway. To gather the speed and travel time, we can simply have just one or two vehicles. Let's say we are calculating by lane, then one or two vehicle in each lane. So to number of data points that is required to get the speed and travel time is lower than to get the volumes. So volume requires getting information on all the vehicles or as much as possible, whereas speed and travel time is kind of if we get information on one of the vehicles, then usually it's good enough estimation. So it's important to remember a concept called sample size when we are working on project, especially on the GPS based data. We need a good sample size if we are working for traffic count or volume. So traffic counts or OD based data need a good sample size, whereas these requirements are typically not there when we are working with speed and travel time. Speed plus travel time data does not need the sample size. Only few vehicles in the system are enough. TxDOT has access to prop-based data such as NRIX, which can be used for traffic analysis. Like I mentioned, this use of NRIX within the TxDOT framework is a little bit tricky. NRIX offers a lot of products. So NRIX has roadway analytics tools. Roadway analytics and some congestion tone. Then NRIX has signal analytics. Then it has TMCs, and also it has OD information. These two are estimated. However, I believe only the roadway analytics is covered with TxDOT contract and not everything is covered. So when we look at NRIX and we look at bunch of information online, it throws a series of information and it has like this, but it's many times it's very confusing to figure out for which we have the TxDOT contract and which we don't. So I believe that roadway analytics is one for which TxDOT has a contract which provides us travel time, congestion, and bottlenecks. Out of these, travel time and travel speeds are most frequently used for calibration purposes. And the same information can be produced by NPMRDS, which is by University of Maryland. NPMRDS, University of Maryland. Next one is Bluetooth sensors data. We can set up the Bluetooth sensor at certain location and they can capture, they can not only capture the volume or a sample of volumes, but they can give us the OD data. So that's the Bluetooth data. So we can capture how many vehicles pass through certain locations, and if we know the sample size, then we can estimate the traffic volume distribution throughout the day. Also, because we can detect the device ID, usually we can detect from where to where they are going on the roadway. Multimodal travel data, typically we collect the pedestrian data, and depending on whether we are working on multimodal project or not, we may or may not use a lot of this data. So I'll skip it for now because multimodal projects are specific planning projects, and the manual has to cover everything, so it's here, but majority of time we do not work with multimodal. Truck is something which is heavily done in planning, and if we are working on planning projects especially related to trucks, then we would collect truck data such as truck percentage, tonnage, parking locations, truck types, and all those information. Next one is safety data. So majority of the safety data or past record comes from a database called CRAS, and this is maintained by TxDOT. CRIS is Crash Record Information System, where we can get a historical crash data for almost all the roadways within the state of Texas. So existing data sources is stars 2, which we have already discussed. So safety data, please refer to section 2.2.1 and 2.2 for more detail on gathering geometric. Chapter 5 and 6 will give more data regarding the safety. So safety data needs an extensive data set. It's extensive data sets, and it's usually difficult to get it covered under this one. So it's referred in chapter 5 and 6. It needs detailed geometry and demographics or driver characteristics, and then it needs traffic information, and the most detailed data that is needed for safety analysis. So it's covered under chapter 5 and 6. Next one is existing data sources, from where these are data sources that does not need data collection, from consultant, data collection by consultants. And we have discussed the biggest one is the stars 2, which gives us past 20 years. Again, I'm just repeating because it's so important. 20 years of historic ADT counts. Then it gives us 15 minute count for 24 hours. Then it also gives vehicle classification counts, vehicle class counts at certain locations, and the number of classes are based on 13 TxDOT classes. We have TxDOT classes, which we have discussed in great length in chapter 2 of the video series, and we have discussed these data sources in the video series we have. So we looked at the stars 2 data. On an average, TxDOT collects 82,000 short-term counts, 1,000 vehicle classification counts station annually. So for majority of our roadway system, we can get traffic data from stars 2. The one thing that stars 2 or any other data sources does not provide, like I mentioned earlier, is turning moment counts, which I wish they would start to include turning moment counts from previous projects, but it currently does not have turning moment counts. Other sources of traffic data. So agencies may have their own sources of data. Sometimes MPOs have their own data sets. These are finer detail which can be read. Tolling agencies may have their own data sets. Pedestrian and bike counts, there is an initiative by TTIs to combine different data sources. So TTI is working on a map which combines different data sources for pedestrian and bicyclists. So that can be another good resource. Big data is refers to a large volume of information, which is usually GPS based data. So there are several firms which collects the GPS based data. I believe from the auto manufacturer, and maybe from cell phones, and then convert them to calculate the speed or velocity. So FSWA defines big data as having at least 7 dimensions. One, it has big volume, velocity, and how fast the data is flowing, variety, veracity, value, people, governance. We can dig more into what is big data as a part of other other videos, but important thing to note here is additional detail provider about big data is Enrix, Replica, Vijo. Streetlight in past used to have a contract with TxDOT, but not anymore. So we do not get access to Streetlight anymore. There are some challenges and limitations with big data. Because big data is based on GPS based data, is a sample data which uses some kind of machine learning or AI to generate full volume. From experience, these volumes are not that reliable. However, the travel time and other parameters are reliable. Let's say we are studying congestion or signal analytics, those will be more reliable. Still an emerging field, as more vehicles are getting fitted with latest equipment. The quality of the data is going to improve in the future. So Appendix C provides information regarding replica data access. These are UAT, user authorization form, to get data for each of the project. Enrix, Replica and Vijo. For every project we work on, we have to fill up user agreement and get it approved before working on a project. So Enrix, we have mentioned it several times. Streetlight data is not in use anymore, but it was a good source of OD based data. I wouldn't say good source, but it was probably the only source in past for OD based data. Also, it has weekday, weekend and by class data. However, the quality of data was questionable. Depends on location. So if we are working on urban areas which has more data points, the quality of data may be a little bit higher than outside of urban areas. Next we have TxDOT Open Data Portal, which we have looked into, which is GIS data portal. We don't need any authorization for this. We can just Google search it and use the data provided by TxDOT. They usually come in CSV, KML, GIS, JSON and other formats, and we can visualize this data on the data portal itself. The data portal is maintained by ArcGIS or ISRE. TxDOT statewide planning map is another great resource we frequently use. Statewide planning map. So one of the drawback of STARS 2 is very slow to load. So several times if we don't necessarily need information that is provided in both of the platform, we typically prefer to use statewide planning map. However, we need to remember that STARS 2 data gives the directional data on freeway and frontage roads, so there will be 4 data points, whereas statewide planning map gives 1 data points where it combines the main lane and frontage road. So there are some minor differences at some locations. However, for majority of cases, statewide planning map loads faster and it has a lot of information such as ADT, speed limit, construction, bridges and many more. Whereas STARS 2 data is specifically developed for volumes or counts, whereas statewide planning map combines the traffic and roadway information and other assets TxDOT has. So statewide planning map is a great tool which we frequently use, especially when we are working on proposal and pursuits. A statewide planning map is heavily used for pursuits and proposals. TxDOT project tracker provides the past, active and planned projects which we use for which we consider for traffic operations, especially in the traffic forecasting, and we use this for again pursuits and proposals to figure out what are the projects that are upcoming in the area, and then what are those influences. Then TxDOT pavement maintenance information system. In appendix there is a form that is given, we can fill out to get this data. We do not typically use this heavily, however the appendix has provided a form if we need to use TxDOT pavement maintenance information system. Is used for storing, retrieving, analyzing and reporting pavement conditions for all TxDOT roadway. So pavement conditions can be used in safety analysis. Pavement conditions. Now Appendix C Section 3 PMI's data request form and PMI's confidentiality agreement is provided in appendix. TxDOT Traffic Management Centers TMCs also has a wealth of data which we can ask for if we are working in urban areas. And there are several detectors that are in the major cities: Austin, Dallas, El Paso, Fort Worth and San Antonio. Actually, for research purposes, a bunch of detectors are located in California, and those detectors provide every 5 seconds of data by lane. I believe something similar is provided in this detector's data, and a sample output is provided in appendix. So sample output is provided in appendix. It's not as extensive as what is used in research on California database, which is PEMS. However, in Texas, these detectors I believe can provide data by lane. They can include speed, volume, at fine time interval. When we collect data, we typically collect for 15 minutes. However, when we have detectors embedded in the roadways, then we can get data every 5 seconds to, let's say, 15 seconds. Fine time intervals. So a lot of this detectors, layout, map and everything is provided in appendix, and we will quickly have a look before moving forward. So this is the appendix. Let's go ahead. External references, project scoping, which we have discussed in previous video. Then we have schedule and methodology, technical memo. So these are the different elements that are typically involved in methodology. Technical memo, a list of key personnels, project overview, then preliminary data review. I believe traffic forecasting is here, but I usually we put it well before, so maybe here or here. Preliminary alternative identifications. Forecasting may come after alternative identification. Analysis tool consideration, initial MOEs, forecasting and others. Traffic forecasting is typically well before the traffic. Forecasting is before the operations, because first we need to know the volumes before we can do the traffic and safety. And then conclusions. Next we have the schedule, preliminary schedule, like we discussed, data collection, This is field visit check. Many consultants have their own checklist, but in the absence of checklist, we can use this one. Index data user agreement. So if you are working on projects, we have to sign this agreement, and this is for each project we have to sign agreements. Then this is PMIS data request form, like it was mentioned. Then PMIS confidentiality agreement, IHS market data release, and external sources. This is traffic management center, which most detectors are set to 20 seconds or 30 seconds. Speed is available per lane. That's good to know. I have not personally used much of detector data. We used to use it, detector data, not for operational analysis, but to gather the performance measure directly from the data. Gather performance measures from data sources. So we will be given a bunch of detector data, and based on the detector data, we would be generating a report on how the roadway or how the traffic is performing, or the roadway is performing. Volume is available per lane. That's very good. It is the actual count per lane during pole cycle of the vehicles crossing the detectors. Occupancy is available per lane. So occupancy can indirectly be transferred into density, which can be transferred into level of service. So occupancy is a very good. Occupancy combined with speed can be transferred into density, and then we can define the level of service. All these calculations has been very nicely described in PEMS manual of data cleaning, data processing. Not all the detector data are clean. I would say 70% is clean, 30% is I would say like poor detector data. So we have to clean this part, and before directly using it, there is some processing and cleaning involved. So all those things are mentioned in PEMS manual on how to clean detector data and how to use it. These are detectors. These are detector locations in the Austin area. So there, the green ones are active, blue ones are out of service, red fail, 0 error. So green ones are, it's hard to see anyone actually active. Most of them are yellow, which are error, and blue, which is out of service. Here as well, most of them are yellow, which is under error. There I can see 1 or 2 green data sources. The one I mentioned in California, if you're working on research, you can gather 5 seconds data, and the detectors are present in each lane, and they are present throughout the city, and it's a big massive database and a massive network of many detectors. El Paso, mostly yellow and blue. I did not see much active detectors here. This is Fort Worth area. I did not see, only one active detector can be seen. I guess for the detectors to be useful, we do not need only one detector. It also needs to be combined with downstream and upstream detectors nearby to get a sense of what is happening. So due to lack of multiple detectors, I would say their usage has been limited. Like I mentioned, we have only used detectors for just writing performance measure reports, but not performance measure reports, but not on actual operation projects. However, for research purposes, we have used detector data from PEMS from California to test out the behavior under certain different circumstances to detect how the merge, diverge and weaving works. Or let's say we are trying to test ramp metering, which requires detailed data. Then we have in past used PEMS database to do some kind of research work. Lone Star San Antonio district seems to have most active detectors compared with Laredo. So Lone Star detector example output, there is the detector name, latitude and longitude will give us the location, speed for 15 minutes, speed second 15 minutes. I guess these are the lanes, different lanes. Oh sorry, so the first 15 minutes, second 15 minute, third 15 minute, fourth 15 minute are the 15 minutes of the hour, and this is the total volume. We'll switch back to the discussion. Then we have travel demand model. We have greatly discussed travel demand model in chapter 3. Please refer to this video series. I believe there are 6 videos, or maybe there are more, that goes through what is travel demand model, how travel demand models are done, how they are built, how to process the output, what are the pitfalls to avoid, and many other things. So I would highly recommend looking into chapter 3 of travel demand models. Crash record information system is where we get the safety data or historical crash data. We have discussed this under chapter 4 of the video series on how to use crash data, how to obtain it, and other things. So chapter 4. Freight data is used for, I have seen being used for planning projects. And then a regional transportation information system, RTIS, is a national database by University of Maryland, which also provides the NPM RDS. I believe NPM RDS is kind of a platform that uses the RITIS data to display the results. So this is a great data source to have. It's a little bit tricky to use, but once you get hang of it, it can be used on many projects. This also requires an authorization from TxDOT.PM to be used. There are 3 main RTS features that helps with the analysis: real-time data feed, real-time situational awareness tool, and archive data analysis tools. RTS data are listed below, and detailed information about each data type can be found on the website. So traffic volume, work zones, crowdsource waste data, weather, signal status. Now it's a massive, it's kind of centralized data source for which feed gets data from signals, GPS, freight, and many other data sources. So it's a pretty good data source to have. Its use has been kind of, it can be used in many good ways, and we have used it on 3 to 5 projects, but we have to see how we can increase its uses, because NREX kind of provides what we need for most part. Field study and observation. So these are some observations which we need to make in the field. There is a checklist that was there. Development data usually comes from TIS and TDM models, travel demand models, and MPO plans. Okay, so this table reflects what are the type of analysis that can be done, and this is the different data that are either is required. For example, for safety, we need to collect the roadway geometry and configuration. So roadway geometry and configuration is required for all of the different kind of analysis. For traffic operations, we need traffic operational data is kind of required for all analysis. Turning moment count is required for intersection analysis, interchange analysis, roundabout analysis, and all the intersection design and micro simulation modeling, traffic impact analysis. So R is required, and PS is project specific, and NA is not applicable. So these are different data types, and these are different analysis type, so we can see which data are required, and most of them are very intuitive, and most of them just come from experience on what data are required. Quality assurance, that's an important aspect. So most of the data, we should not just go and collect the data, we should go and collect the data and check the quality of the data. Check quality, consistency, and reliability of data. So quality assurance is not the quality of work, is the quality of data. Quality of data we are collecting and using. So check the quality and coherence of data. Checking the quality and coherence of data is a critical part of data collection process. The result of analysis depends on the quality of data collected. It is recommended that field visit be made during the time when data is being collected. Field visits can help us verify the ground truth, any issues that could arise later when checking the data. So when we collect the data, we check for consistency, and specifically when we use the big data sources, then we check the quality of data. So we can use multiple sources to supplement the analysis with different data sources. However, many times some data sources are more reliable than another, so we have to make that judgment on project by project basis. So we need to see whether the data is complete. For example, if we are working on a freeway and then we have these ramps, then we need to make sure we have the volume at all the locations. Let's say at one of the locations this volume is not that reliable, then this data source is not complete. Accurate is the accuracy of the data. We can check by looking at the pattern or by comparing it in stars to. If it's deviating too much from stars to data collection, then the data may not be good. So one good source of checking the accuracy is balancing, and stars 2 is the TxDOT website. Then discrepancy, it is recommended that all data collected such as traffic count, speed, and travel time be checked against other days of data collected for the same data type. So it's just making sure that the data we are collecting is of high quality. Otherwise, like I mentioned, there is a term called garbage in, garbage out. If we do not have a good quality of data, then we will end up with poor quality results. So it's very important to check the quality of data and through various sources and before using it. Just because there is a data doesn't mean it's a good data to use, and big data sources are a great example of those. They are very good data for certain kind of analysis. For example, reliability analysis, which is almost impossible to do without big data sources. However, we need to know the limitation of data. So they may provide us a volume data or OD data, but we need to see how good those data sets are. So big data sources enables us to look at trip patterns, which is again trip pattern throughout throughout the state, so which is again very difficult to get using conventional means. So big data sources have a lot of positive but also some negative, and we need to be aware of what are the advantages and what are the limitations of the data sources and how reliable they are. So that concludes chapter 2. In the next chapter we will talk about traffic volume forecasting. For the next one we will refer back and forth with chapter 3 we have in the video series of the same traffic volume forecasting, where we go through how to perform traffic volume forecasting using travel demand models, using traffic impact analysis, using growth rate method, and many other things. So we will refer significantly to this chapter 3, which is a part of video series. So please refer to that chapter if you are interested in learning more on traffic volume forecasting. In this chapter we will mostly look at tools that are recommended to be used by TSAP.